Hi guys. I think you're able to hear me. Quickly confirm whether I'm audible or not. I want you to quickly confirm. Hi, Raveen. So you're saying hi means I guess you're able to hear me, right? Cool. So we are in the session PYQ session, previous year questions for KPTCL. Okay. So you already done some questions in the previous session. Now it's the second session of the series. So I'll continue those. Okay. Yeah. Thank you, Kaushik. So let's get started. Let's get started with the question, today's question. If you're ready, give it a thumbs up quickly. Give it a thumbs up. Those who are ready, give it a thumbs up. We'll get into the first question. And we ended up in the previous session, we done with this question. Okay. So 10th one. Now we're moving to the 11th question. I want you to hit the like so that I feel like you're all ready. Okay. If you can share the session, share it with your friends. Okay. So that everybody will get benefit out of it. Now get ready for the first question for today. That's question number 11. Okay. Yeah. It's on the screen. Question number 11 says, what is this? The timer is running already. The timer is running. You're not able to see the timer. Okay. There is a glitch with the timer, I think. We'll fix it up. Screen is black. Is it for everybody or only for a few? Okay. There is some delay, I think, in the stream. Tell me if everybody is facing the same issue or only some people are facing this issue. Screen issue. Is there any delay you're feeling experiencing or is it smooth? Kindly confirm, guys. Is it smooth or you're experiencing an issue? Yeah. No, it's clear. Okay, good then. If it's clear, then I think I'll have to go back to that question once again. Okay. So I'm moving to the question once again. Let me restart the timer as well. Now I want you to answer quickly. Yeah. Yeah. Okay. Answer. Focus on the answer, guys. Praveen, Naveen, Madhan, Kaushik. And a lot of such questions, subject wise, topic wise questions, level wise questions, along with the explanations are there. Just go to the app, you'll get all those details. Quickly give the answer. Timer is running. What are you doing? What are you waiting for? Formula? What is the formula? Okay, you're giving a formula. Great. Rho L by A is a formula, direct substitution. But here there is a point which you need to observe. Though it's a direct substitution, there is a slight point which normally you may get trapped here. Okay. So when you solve it, you will get to know what is a trap there. If you just take it as, okay, it's a resistance, rho L by A formula, then you may get trapped in the exam. Now when you try that, you will get to know what's a trap. I want you to try. Then only you will get to the trap. Yeah, are you not having quick calculation skills? If you're not, okay, what to do? Get a calculator. Or you can guess, with rough calculations, you can guess the answer. What could be the possible answer? Okay, I think let me solve it. Let me solve it for you. Okay, Nagendra said answer is C. Okay, let's see. What is the resistance of 160 centimeter wire with uniform diameter of 0.28 mm if the specific resistance is 12 point. Specific resistance means what? It is the resistivity. Specific resistance means resistivity rho. Okay, and you have to bring units common. Okay, you need to bring it to either centimeters, it's okay, fine, or you can bring it to millimeters, it's fine, or you can bring it to just SI units, meters, absolutely fine. Okay, so balancing unit is very important here. Okay, now choice is yours where you want to bring it. Okay, now if I convert this into meters, okay, SI system, so 12.32 micro, and centimeters I'm converting into meters, so that is 10 power, tell me how much, -2 micro. Micro is already written there, so ohm meter, this is the value of rho, this is the value of rho. Now value of L, what is the value of L? L is equal to 160 centimeters, so 1.6 meters. And area of cross section we want, because we know the formula, R is equal to rho L by A. So area of cross section is, diameter is given in terms of millimeters again. So area is pi r square, R value is 0.14 millimeters. Convert that millimeters into meters. Tell me, what is the conversion? What is the conversion? What I should multiply with what? 10 power? Yes, 10 power -3. Milli means 10 power -3. Okay, meters. So now I took milli here, so it is in meters, pi r square. So now area you will get it as something, you know, all these. Okay, so answer will be, we'll get it as this. Okay, yeah. If it not given area, sir, what do you mean? If not given area means, anyways, so we're done with this question. Units, balancing unit is a key aspect. Okay, specific resistance, don't think that specific resistance is something else, it's resistivity. Okay, shall we move to the next question? Give it a thumbs up, give it a thumbs up, give it a thumbs up, so that we'll go to the next question. Yeah, done. I'm moving to the next question. Timer is running. Timer is running. Yeah, formula, yes, you're mentioning everything above. Okay, yeah, if area is not given, okay, you get the formula, absolutely true here. Lovely. Yeah, all of you, give it a thumbs up, give it a thumbs up, give it a thumbs up. And those who are watching, maybe after this live, if you're watching the rebroadcast, then write the question and mention your answer as well in the comment. Okay, and if you want more such kind of, you know, questions of different levels, what you need to do, download the app. Free questions will be given every week. You will get from one subject, you will get some questions, will be some interesting questions will be asked, MCQs, test will be given, free test will be conducted. Okay, so just go and get the app, you will get the benefits what everybody is getting. Okay, so download the app. So you got just 10 seconds. Okay, so people are saying answer as A. For this question, all of you are saying A is answer? Seriously? Nagendra? I think there's something wrong. There is something wrong. Such an interesting question. You missed it. Oh no. B, encyclopedia. Triply encyclopedia is saying answer is B. Then what others will do? Encyclopedia must be having everything. Okay. So, okay, let's come to the question. Understand the question. Consider a cube of a material of sides 1 centimeter with a resistance of 0.0030. Means there is a cube given 1 centimeter sides, it is having a resistance of this much between the opposite faces. What is the resistance of the same volume of the material is drawn into a length 50 centimeters with uniform cross section? Means that that cube is stretched. The moment that 1 centimeter cube is stretched, what happened? Tell me, volume. Do you think there will be any change in the volume? Tell me quickly. There will be any change in the volume? Tell me. Yes, to answer it, yes, absolutely. C is the correct answer. C is the correct answer. Now let's get to this. Tell me, volume, no change in the volume. Why volume will change? You're stretching it. You're not extending it. You're stretching that material. Okay. Same volume, it is given here. If the same volume of the material is drawn into length, that same volume is drawn to the length. Okay. Volume is not changing. Okay. So volume will be the same volume. Okay. And it is stretched to 50 centimeters. Okay. And uniformly stretching. Now what will happen? What's the volume of this cuboid? Cube. What's the volume of the cube? 1 centimeter cube. 1 centimeter cube is the volume of the cube in the case 1. Okay, in the case 1, when you have a cube, volume is 1 centimeter cube. The moment you stretched it, that's what case 2, volume is still 1 centimeter cube. You stretch to how much length? You stretch to how much length? You stretch to 50 centimeters. 50 centimeters. Okay. Means the other side, what happened to the other sides? Other side is reduced by 50 centimeters. Other side is reduced by 50 centimeters. Now, if I apply a formula R is equal to rho L by A, what happened here? Rho is not changing because the material has not changed. As you have not changed the material type, rho is constant. Rho has not changed. Okay. Now tell me what happened to the area of cross section. That has reduced by 50 times. Length has increased by 50 times. Okay. Length has increased by 50 times and this has reduced by 50 times. Now what will happen? 50, 50, 2500 into 0.033 is 0.003. What is the resistivity definition here? I'm using the same units, centimeters all throughout. Okay. So resistivity definition what? It is a resistance of 1 unit cube. So it is given a resistance. Means what? Resistance of 1 unit cube means all dimensions are having 1 unit. Then its resistance is this much. Means the resistivity of the material is given as 0.003. Now I'm using that resistivity. Now this formula, when I multiply with it, 0.003 into 2500, you do it, you will get a 7.5. Are you clear with this? Are you clear with this? Shall I move to the next question? Here the main catch point here is understanding this as a resistivity. You have to know the definition of resistivity. Yes, good. At least Nagendra is positive in this. He said yes. I'm moving forward to the next question. Boom. So, timer is already running. Timer started already running. You go to the question, quickly answer the question as well. Yeah. Meanwhile, let me go to the comments. Good, good. Thumbs up. Give it a thumbs up. Give it a thumbs up. Nice. Okay. Praveen has answered quickly. Rather than quick answer is appreciated. Okay. Muhammad Hafiz has given us option D. Let's see how many will give the correct answer. Oh, encyclopedia is saying D. Great. Akash Rathod is saying D. Okay. Did you like the video, guys? Like, hit the like. That's a fuel for us. That's a fuel for us. You're just simple act of hitting like is a fuel. Okay. I know you guys are crazy. You don't want to fuel us. You want to take the fuel, but you don't want to fuel us for free. No, crazy bugs. Nagendra is saying, see, come on, yeah. What happened? What happened to Nagendra today? What happens to the Nagendra? What happens to the resistance of a wire when its length as well as a cross-section area is doubled? Alright, it's the simplest thing. Length is 2 times R is equal to rho L by A. Length has increased by 2 times. Area of cross section also increased by 2 times. 2 get cancelled. Resistance is 4 times. No change. No change. No change. Answer will be C. No. Why answer will be C? Cross sectional area is doubled, right? Why answer will be C? Why answer will be C? Answer is D. Simple thing. After 1 minute 30 seconds, you marked wrong answer. Come on. Next question. Next question. Tell me what you have to do to get more such questions for free. Every week, you will be getting such interesting questions along with explanations in the app. You will be conducted a test, free test. Okay. There are some free videos also available. Go ahead, enjoy. Okay, your brother is typing. Okay, nice. Now, you look into this question. You answer it. 0.125 farad. Is that what you mean, Dharmendra Sahu? I think Nagendra is a guy who gives the explanations as well. Means he'll get the formula, he'll put a lot of efforts in solving it. That's good. Really good, Nagendra. Yes, you're absolutely right. You need to recall. That's how you need to recall. This PYQ session is not just to answer the question, to recollect steps. Okay. Yeah, you have time, right? 1 minute 30 seconds time is there. Within that time, try to recollect as much as you can. Microfarad. Yes, yes. Yes, Dharmendra, that should be. 0.125, it's there in all options. But microfarad, millifarad, farad, that you need to set. Time's up. Time's up. Okay, fine. You don't have a calculator, that's why. See, you need to at least give a guess without a calculator also. You should do some mathematical jugglery and you should try to guess what will be the possible value. Okay, let's try to do that. Do that. I'm not using a calculator here. Okay, none of the above is there, so there might be a trap. You need to be careful. What is the capacitance? When capacitor passes a current of 31.43 milliampere, means I have a capacitor which is carrying a current. This idiot capacitor is carrying a current of 31.43 milliampere. Tell me why this is carrying current? Because there is somebody who is driving this current. There is some voltage which is driving this current. Okay, so definitely it must be AC voltage. This must be AC voltage. So that is having a frequency of 1000 hertz. Can you tell me what is this 40 volt 1000 hertz capacitor? 40 volts and 1000 hertz, not capacitor, voltage source is driving this much bloody amount of current. Tell me what is the value of XC? XC is equal to V by I 40 by 31.43. Okay. So now, as we don't have a calculator, so this is milli, absolutely, yeah, it is a milli. So now, We know XC is equal to, Nagendra also rightly said, 2 pi FC. Okay, so in place of XC, just put here 40 by 31.43. Here you keep 1000. This is milli. So milli 1000 and here it is C. So take C here and everything else into the other side. Then what will you get quickly? C is equal to, this is, you will get it as 40, it's gone to the other side. Okay, 31.43. This is milli and this is a kilo in the denominator. Once it goes to the numerator, it will be micro. It will be a micro. It will be a micro. Okay, and what else we have? Into 2 pi by 40. Okay, so yeah, now you have to do this mathematics. Definitely possibly it won't be like C, because if you just do this math operation, you will not get 1257, and definitely not even this. You will not get 0.125. No, I think you will get 0.125 only. Okay, it's not this. It's not just farad. Okay, it isn't microfarad what we got here clearly. So possibly this is answer. Okay, not A, Madan. Come on, it doesn't allow suddenly change voltage capacitor. Yes, you're absolutely correct. Okay, okay. So now onwards to I give max correct answers. Yes, everybody try to give the correct answers. I hope you also will achieve your target of giving correct answer. Now coming to the next question. I want everybody to attempt this question. Try doing it. It's the simplest question. You don't have to use this entire 90 seconds time. Within just 30 seconds, you can answer this question. How many seconds? 30 seconds. Answer it. Surprise. I'm surprised. I didn't get answers yet. I expected in 30 seconds. Good. Manikanta, you hailed it because you're the first one. C. Naveen is saying C, not just one C. He had 4 C's in a row. Okay, Naveen, good. Nagendra is back to his formula as well. Before me, I think he's giving the formula. That's great, Nagendra. Lovely. Okay, so C is equal to Q by V. Okay, so what? That's what he is recalling. He is recollecting whether it is related to this or not. You have to recollect the concept related to this. Capacitors, when they are connected in parallel, when they are connected in series, you will apply resistance parallel formula. Okay, C1 C2 by C1 plus C2. Yes, Dharmendra Shahu. Now he is also back with his formulas. Dharmendra Shahu is competing with Nagendra. That's lovely competition. Energy stored is equal to half CV square in case of a capacitor. In case of an inductor, half Li square. Okay. C and L, they are dual to each other. C and L are dual to each other. V and I are dual to each other. Just a duality concept you apply. In case of transients also, tau is equal to RC, time constant RC. In case of RL circuit, RC and RL circuit are dual to each other. Tau is equal to, in place of C, you place L. In place of R, you place 1 by R. Duality concept. So tau is equal to L by R for RL circuit. For RC circuit, it is RC. I gave you such a lot of interesting tips and interesting analogies are given in the course. Just go and watch free videos, download the app, start watching the free videos. You will get a lot of things. Okay. So anyways, coming to the question. In the question, it is asked for half CV square. By the way, do you know this duality concept given the comment quickly? Do you know this duality concept? Duality, what I said, tau is equal to RC. Duality is L by R. Anyways, keep typing. I'll just, do you know the value of C? 7 microfarad into 200 square. Okay. So yeah, solve it. I think you must be getting this as answer. Okay. See, you're not allowed to use a calculator here. You're not allowed to use a calculator here. So you need to be smarter, and because none of the above is there, none of the above is there. So your aptitude skills also are getting tested in this question. Yeah. If none of the above is not there, then things would have been a little more easier to pick up the answer. Anyways, okay. Shall we move to the next question? Shall we move to the next question? Give it a thumbs up if you're ready. Next question. Can you tell me what is the relation for capacitor and permittivity and the distance between the plates and the area of cross section? Tell me relation between, just to recollect, C, epsilon. C is a function of epsilon, which is permittivity, area of cross section of the plates and distance between the two plates. Yes, quickly tell me. Tell me. I'm waiting. Epsilon A by D. C is equal to epsilon A by D. More the distance between the two plates. Simple. Don't get confused here. Sometimes some people will get confused with this. C is equal to epsilon D by A or A by D. They'll get confused. Not this. Because more the distance between the plates, then you will have less capacitance. Lesser the distance, you'll have more capacitance. Okay? Then move to the next question. Give it a thumbs up. Give it a thumbs up. Give it a thumbs up. Yes, Dharmendra. You're absolutely true. Sanjay is also saying. Sanjay is also saying. Pawan Kumar has retracted. He's asking about some measurements videos, I think. You'll get it. Okay. I'm doing, it's actually my delay. I was doing that. Yeah, I'm saying, right? We're on the way, we're in the process, Pawan. My team has informed me also. Some people are requesting for those. Yeah. Series for 2πfc. Okay, let's see. Let's see. Here we recollected. Even he said, Nagendra said Q is equal to some formula. All those things will be here applicable. Careful. Interesting, very interesting question. Simple question, but very simple question, but an interesting piece of question. I want you to quickly answer. 8.854 into 10 to the power 12 farad per meter. 500 microcoulomb is the answer which is given by Sanjay. Give it up to Sanjay. You're absolutely right, Sanjay. You're absolutely right. Okay, let's see. What is the charge on each capacitor when a 150 volt is applied across two capacitors with values 5 microfarad and 10 microfarad current in series? So this is the capacitors connection, 5 micro and 10 micro, and you will have uniform charge in both. You'll have the same charge. Okay, the charge will be, tell me what will be the equivalent capacitance when you have two capacitors are connected in series. The equivalent capacitance will be how much? Can I simply add these two capacitances because they are in series? We can add them to get the equivalent capacitance. Can I do that? No, I cannot do that. For capacitor series, farads are given. If you have unit, ohm is given, here ohms are given, then I can add two ohmic values. But farads, we cannot do that. Okay, so C equivalent will be highest value, which is 10 micro by 2 times more, 2 plus 1 is 3. So 10 by 3 micro farad, which is 3.33 microfarad, which is the equivalent capacitance. Now what is the total charge? Q is equal to C into V. Now C value is this, V value is this. Simply Q is equal to C, which is 3.33 micro into 150. Okay, so 150 into 10 is 500. 1500 by 3 is 500. 500 micro is as it is, because if I don't do this simplification, simply you keep this C equivalent here, 10 micro by 3. So 3 here 50 and 500 microcoulomb. So this is what the equivalent charge, and the same thing will be here. Okay, same thing in this capacitor, same thing in this capacitor as well. Okay, now if you want to find out what is the voltage across this capacitance and what is the voltage across this capacitance, how do you do that? How do you do that voltage across these two capacitances? Either you can apply voltage division formula with respect to capacitors. With respect to capacitors, you can apply voltage division formula, or you know the charge, you know the capacitance value. You can use this formula where B is equal to Q by C. You know the charge, you know the capacitance value. So you can find out what is the voltage across V1 and V2. Yeah, you try doing that. You try doing that. Okay. So who said exactly very nicely? Somebody said. Okay. Okay. Let me go to the next question. Let me go to the next question. Give it a thumbs up. Give it a thumbs up. We'll go to the next question. Give it a thumbs up. Thumbs up. Taste the thunder. Yeah. Voltage division rule. Cool. VDR. Voltage division rule. Absolutely. What is that voltage division rule? People do forget that. Do you know that? I think I must have forgot that also. Don't forget. Which is voltage division rule, current division rule, equivalent resistance. You might be thinking they are the simplest thing, they are useless things. No. Throughout your course, till the transients, these basic things will help you a lot. KCL, voltage division, current division, we forget. But you just go and watch those free videos available in the app. You won't even forget that. Because a lot of beautiful tips are given to remember those. You will never ever forget any one of those formulas. Resistance, series parallel connection, you will not forget that. Nothing you'll forget. You will rock. Yeah. Yes. Vinod is back. Vinod, you're late today. We're missing you. We're missing your answers. We already got the answer. Yeah. It's an easy one, I think. What happens to the capacitance if mica is inserted between the plates of an air capacitor? Air core means there is nothing in between two plates. Now, the moment you insert a mica sheet, what's going to happen? Just now, recollecting the formulas will help you. We recollected the formula C is equal to epsilon A by D formula. So air compared to air, mica is having little higher relative permittivity. So epsilon will be more. As epsilon is more, capacitance will be more. And you just recollect what is the value of, you don't have to recollect, by the way, they will give you the relative permittivity of mica if it is required. But now it's a qualitative information. We know it is more. As it is more, capacitance will increase. So answer is A, absolutely true. Shall I go to the next question? स्पीड इंक्रीज करो. किसका स्पीड इंक्रीज करो? टाइमर का. मेरा स्पीड इंक्रीज करो. जवाब देने का स्पीड भी इंक्रीज कर दो तो स्पीड will be increased automatically. Yeah. Next question. I think those who want quick questions and more number of questions, tough questions, keep giving. Free tests are coming every day. One free test is coming in the app. You need to answer them. That's it. You will rock the subjects. Okay. One test will be coming up for you. Okay. Just for free. Download the app. Enjoy the content. And share this video. Crack the exam. You got 30 seconds left. We only got few questions only. This is a simple one. Come on, why are you taking this much time? Dharmendra, where are you? You're gone. You're back. Okay. Navin is saying A, Dharmendra is saying C. Speed increase करने से फायदा क्या भाई? Hi sir, how are you? I'm perfect. Super fine. Okay, I'm back to the question. In a battery, the difference between no load voltage and measured voltage output. So when you have a battery, let me take this dabba, this box as a battery. The moment you're just measuring a no load. When it is at no load, you're measuring its voltage. And in the second case, what if you're measuring its output voltage? When there is something connected, when there is some load connected, you're measuring this terminal voltage. There is a difference coming up. Why the hell is the difference coming up? That's because this battery is having some internal resistance. Some internal resistance. Because of that internal resistance, the voltage is dropped. So answer is not external resistance, it is internal resistance. Are you clear? B, Ashwini, you're absolutely true. We are going to the next question. Now tell me, voltage source, internal resistance, ideal voltage source. I want you to pay attention. I'm going to give you a super tip for you to remember at least. Some of my students do forget. Voltage source, ideal voltage source, internal resistance is how much? Tell me. I want everybody to answer here. Similarly, ideal current source, internal resistance is how much? Yes, it is 0 here. It is infinity here. To remember this, I will give you a tip, remembering tip. Voltage. Okay, this is a voltage. Voltage you have here. What is this? Oh, 0. So internal resistance is 0. Don't get stumbled or confused. Current. In the spelling of current, you will not see any 0. So internal resistance is infinity. Take it as that. Remember this tip. Just a bullshit logic to remember this. Simple. But the perfect logic, you will never miss this. In any situation, if somebody wakes you up and tell me what is it, ideal resistance, ideal voltage source, and internal resistance. No confusion. Voltage 0 is there, internal resistance 0. Simple. I'm moving to the next question. Did you like this tip? Give it a thumbs up. Inductance and resistances are 0 for ideal. Yes, absolutely true. Nagendra is rocking. Rockstar. Let's go to the next question. Quickly. We're going to the next question. Yeah, answer it. Fast. Super fast. Wow. So as most of you answered quickly, so I'm not considering the timer. Okay. I'm bypassing the timer. Because you really answered. You hailed it. What is when the difference between two sinusoidal quantities are 90 degrees? We'll not say the right angle, all these things. That's a mathematical terminology, right angle to each other, all these things. But in case of electrical terminology, we'll call them as phase quadrature. What's that? Phase quadrature. If both are in the same phase, we'll call it as in phase. If they're opposite to each other, 180 degrees phase shift, we'll call it as anti-phase. Okay. Next question. Next question. Timer is running. Yes, good. For a resistor, it is in phase. And guys, there is a beautiful video. If you are confused with the phasor diagram, complete concept, complete understanding, leading, lagging, all these concepts, complete understanding is given in the app. Download the app for free. You will get that complete understanding. You will be able to bloody draw for any equation. You will be able to draw the phasor diagram once you watch that free video in the app. Try doing it. Yeah, what is this leading? What is this? Blah blah blah. Why inductor will lag? Why capacitor will lead? All the reasons are there. You watch it. You're gonna love it. That's one of our popular videos, rather. Okay. Okay. Again, simple. Cluster factor or peak factor. In the previous lecture, we discussed about these factors. Okay. Peak factor, cluster factor is maximum value by RMS value. Okay. Maximum value by maximum amplitude. Amplitude itself means a maximum value. You don't have to say maximum amplitude. Okay. Amplitude itself means it's a maximum value. Amplitude by RMS value. C is the answer. Okay. That's for the peak factor. Tell me what if it is for the form factor. For a form factor, the formula would be, just to recollect, RMS value by average value. What is the significance of this peak factor? What is the significance of this form factor? All these things I had discussed already in the previous lecture. One was the previous lecture. Okay. So that is it. That is it for today's session. I'm ending this session today. Okay. I'll catch you up in the next session tomorrow itself. Okay. So what all you need to do, download the app, enjoy the free test, enjoy the free content. Okay. Bye-bye.